All right, problem number 16 says Jose had 4 times as many trading cards as Philip. After Jose gave away 50 cards to his little brother and Philip gave 5 cards to his friend for his birthday, they each had an equal amount of cards. How many total cards were there? So I'm trying to figure out how many total cards there are, and we're talking about how many total cards there were between Jose and Philip when they started. All right. So I don't know how many Jose had, and I don't know how many Philip had. I'm going to have to use variables to represent the number of cards they each have. So what letter do you think we could use for how many cards Jose had? Hopefully you thought of J, all right, something that is associated with Jose, and then maybe P for Philip. Okay, so we're going to use J for the number of cards Jose has, P for the number of cards that Philip has. Hopefully you realize when you see this, anytime you're talking about like two numbers of values that you don't know, like I don't know how many this person has or this many, how many this person has, but you know that they compare in some way to each other, like one has 4 times as many or 4 more or 10 more or whatever, and there are like 2 sentences of information. Usually this is a systems of equations problem. Okay, and the way we do it is we define our variables, which we just did. We're going to call J the number of cards Jose has, and the number of cards Philip has we're going to call P. So now we just need to write a couple of equations here. So what I'm going to do, let me lower this down, I don't need it just yet, but it said Jose had 4 times as many as Philip. So for instance, let's say Philip had 10. Jose has 4 times as many as Philip, so that would be 4 times 10, which is 40. So that means I need to take whatever Philip has, all right, which we're going to call P, and multiply that by 4 to get Jose's number. So I'm going to come over here real quick, and I'm going to say, okay, that means that Jose's is equal to 4 times whatever Philip has. 4 times P or just 4P. All right? So that's the first equation we have. Now we also see that after Jose gave away 50 cards, so if he's giving them away, what does that mean we're doing to his total? He's giving those cards away, that means we need to subtract them. So he gave away 50 of his cards, and if we look, it says Philip gave 5 of his to his friend for his birthday, and who cares why he gave them to his friend, all right? The birthday, it's his friend, the little brother, all these things are just distractors. That doesn't really matter. We just know Jose gave away 50, Philip gave 5 in this case, all right? They're not giving them to each other, so they're the second piece of information there, who he's giving that to, that doesn't really matter. So Philip gave away 5, so that's P minus 5. And we see that after that happened, they each had an equal amount of cards. That means whatever this number is going to be equal to whatever this number is. So now I've got a system of equations, 2 equations, 2 variables. I should be able to solve this. So let's look at this in a little more detail. If you look at this first equation, I know that the letter J is equal to 4 times whatever the letter P is. Right? That means this is going to be a substitution problem. Okay. Now I could use guess and check. I could just start guessing a bunch of numbers for J and P, picking numbers that are for P and then multiplying by 4 to figure out a J and see if they work in this equation. But if we use substitution, we can get this pretty quickly just using algebra. Notice J will be equal to the same value as 4P. That means anywhere a J shows up in the other equation, I can replace it with 4P. All right, and that's what we talked about when we used the term substitution. So 4P minus 50 now is equal to P minus 5. All I did is I replaced this J right here. Since those are equal to each other, I can replace this J with 4P. All right, I did a substitution there. So now this is one equation with one variable. We can solve this. All right, it's the same variable on both sides, so we just consider that one variable. So let's think about what we do. I want to get my letter P's on one side by themselves. All right, so I've got 4P here, 1P over here. I'm going to just take away this 1P. All right, I'm going to put a little number 1 in front of that. Be very careful. Understand, taking away P is not going to just remove the letter. We just have to think about how many P's we had, 4P, minus this 1. So 4 minus 1 leaves me with 3P, or 3 times however many cards Philip had. So 3P minus 50 equals, this cancels out, and we're left with negative 5. Now let's go down here. To figure out how many what P is, we need to solve for P. First step, I need to add 50 to both sides. Cancel out this minus 50. Again, we're trying to get the letter P by itself, so this is canceling something out. I'm left with 3P equals negative 5 plus 50. You may know that in your head or be able to do it in your head. If not, plug it in your calculator. Negative 5 plus 50 is 45. And now one more step to solve for P. 3 times P is equal to 45, so if I divide both sides by 3, that should tell me what P is equal to. And if you do 45 divided by 3, you may be able to do that in your head. Again, if not, plug it in a calculator. 45 divided by 3 would give you 15. Okay? So that's how many cards Philip had when we started. Now, let's figure out how many that Jose had. We always want to plug it back in to one of our equations. So I'm going to go back to the substitution equation that I used, and usually that's the one that's going to be easiest to plug it into. So that means Jose's number will equal 4 times Philip's number, which is 15. All right, and again, you might be able to do this in your head. If not, plug it in a calculator. 4 times 15 is 60. So Philip had 15, Jose had 60. Let's look at the answer choices here. There's 60, I don't see 15, but look at what it's asking. It said how many total cards were there. So between the two of them, how many cards were there? Well, originally, Jose had 60, Philip had 15. If you add up 60 plus 15, what do you get? You get 75 total cards. So the correct answer in this problem is going to be B. All right. So hopefully that made sense. If not, again, go back, watch it again. If you have trouble, if you missed something, just rewind it, slow it down. You can pause it, think about it for a minute, catch up, and then just continue the video. Hopefully it'll make sense. You can always leave comments if you misunderstood something, or you can ask me in class. But hopefully you got it.